In this tutorial video, we are going to learn how to find the distance to something and its height without actually being able to pace off that distance. Let me draw what I'm talking about here. So let's say that we have some point right here. It's the top of a tree or the top of a lighthouse or the top of a building or the top of a mountain. And we are starting over here. Okay, so that's where we are at first. Now, how would we find the distance, the height of that point above the ground, or our distance to that point? You could think of a lot of navigation situations, surveying situations, where you would want to know this. You could say, well, why not pace off the distance, heel to toe? Okay, well, what if this is several miles away? The only way to do it is by using some clever trigonometry and pacing off a small distance. So maybe you can sail or walk a little bit closer to the point, and now you have these two angles right here. Okay, and they are relative to each other. I'm going to make sure this about the same size here. Okay, so in reference to ground level, this angle here, we're given this angle here as 36 degrees. And this angle here we're given as 52 degrees in the example problem. And what we would very much like to know is the distance from this point to, so let's say, the ground. Okay, so we'd like to know the distance from this point to the ground. And we'd also like to know the distance from our original location or our secondary location here. Now, the only other piece of information we're given is we are given this distance. That distance right there. We are given this distance, and it is 5 feet. All right, so what do we do? Right, that's kind of the million-dollar question. Well, let's complete the triangle so we have a complete picture of what we're looking at here. Just drawing these lines. And now you should be getting some kind of hint, because if we've drawn the lines correctly, this will form a right angle. Right? My camera's it's distorting it a little bit, but that's vertical. Okay, so we don't know this distance right here. We'll call this unknown distance L. Okay, we don't know that distance, and we have this height right here that we don't know, and we will call this unknown height H. Okay, so this is the information we have, and maybe we should label these points with letters just so we can refer to them. We will call this A, and we will call this point B, and we will call this point over here C, and we'll call this point up here D. Okay, so here's what we have to keep in mind. That let's think about our trigonometry formulas. What can we do here? Well, this triangle, DAC, this huge triangle here, has this DC, height. This smaller triangle, DBC, also has this DC as the height. So let's think about the SOHCAHTOA mnemonic. This is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. All right? Well, as it turns out, the tangent function will be the most useful function for us because we know part of the adjacent angle, or part of the adjacent side, and we want to know the height. So we are concerned with these two sides, the opposite side and the adjacent side. So we are going to focus on the tangent formula. So tangent is equal to opposite over adjacent. Okay? So what that means is that in the case of 36 degrees, the tangent of 36 degrees is equal to h over 5 plus L. Okay, the tangent of 36 degrees is equal to the opposite side over the adjacent side. The opposite side is h, the adjacent side is 5 plus whatever that distance is, L. And that's okay. We'll just leave it just like that. We should also notice that if the tangent of 36 is h over 5 plus L, then the tangent of 52 degrees is equal to h, remember opposite, over, for this littler triangle, the adjacent side is just L. So h over L. Okay, so now we need to set up these simultaneous equations to have both the h's alone. So we'll solve for h in both of these equations, and then set the equations equal to each other. Almost like we're solving a system of equations using substitution. So in order to do that, my first step for this equation right here is to multiply both sides by 5 plus L. Okay, 5 plus L and 5 plus L. On the right-hand side, 5 plus L cancels out in the numerator and denominator, and I'm left on the left-hand side with 5 plus L in parentheses, multiplied by the tangent tan of 36 degrees equals h. Okay? Good. So now we'll do the same thing over here. I'm going to multiply both sides by L this time. The L's cancel out on the right, and I'm left with L times tan of 52 degrees equals h. Okay, so now we need to set these equal to each other. But before we do that, I need to distribute this tan of 36 inside the parentheses, and then I'll set them equal to each other. So I've got 5, I'm just distributing tan of 36 through the parentheses. 5 tan 36 degrees plus L tan of 36 degrees equals, now hold off on writing H because what I'm going to do is set it equal to this, equals L tan of 52 degrees. See, I'm dropping the H's. I'm dropping the H's and I'm setting the things that the H's equal to each other. Okay, so now what is my goal? My goal is to isolate the L's. See, now I want to isolate the L's. Isolate and solve for L. All right, so what I'll do is subtract L tan of 36 degrees from both sides. Okay, on the left, those cancel, and I have 5 tan of 36 degrees set equal to L tan of 52 degrees minus L tan of 36 degrees. And now what I will do is factor out L on the right side. So on the left side, I've still got 5 tan 36 degrees equal to L, which I've now pulled out, open parentheses, tan of 52 degrees minus tan of 36 degrees. Okay, so I'm almost there. Now I just need to divide both sides by this long expression. So divide both sides by open paren tan of 52 degrees minus tan of 36 degrees on both sides. On the right side, these cancel out, leaving L by itself. So L equals, I'm going to flip this now. So, well, I won't flip it. I'll just say this equals L. L equals 5 times tan of 36 divided by tan of 52 minus tan of 36. We need the calculator for this. Okay, if you haven't already done so, it's good to clear the memory. And then for this problem, we want to go to mode and put the calculator in degree mode, since we'll be taking degree inputs. Okay, so then hit second quit. And now what we'll do is try to make it look exactly like what you're going to see there. Hit alpha y equals and then enter, so we get this fraction entry. And we'll type 5 times tan of 36, close parentheses, over, open parentheses, tan of 52, close parentheses, minus tan of 36, close parentheses, and close parentheses. That's the whole thing now. Just hit enter, and you get 6.1 6.564363.066. That's the approximately equal to L. And that's in feet, I should say. It's in feet. So that's this distance right here. So now we can find AC, the full distance, 5 plus L. So you can kind of make a little if-then statement here. If 6.564363.066 equals L, then 5 plus L equals 11.56 43307 feet. And the reason I'm leaving this intermediate value really long is because we're going to be using this value to compute another trigonometry function, so I don't want to clip it too early. Because now I'm going to use the fact that I know L and I know 5 and I know 5 plus L. I'm going to use that to compute H. It's going to be really easy. So remember, recall that tan of theta equals the opposite over adjacent. So the tan of 36 degrees should equal H over 5 plus L. Well, we don't know what H is, but we do know what 5 plus L is. 5 plus L is that, 11.56436307. So if I want to get H by itself, I just multiply both sides by 11.56436307. Okay, and on the right they cancel. And so H is equal to 11.56436307 times the tangent of 36 degrees. So I can just take my answer that I already had stored in there times the tangent of 36 degrees. And I get 8.402. So we will round here to the nearest tenths place and say 8.4 feet is H. Now we can verify that. We can verify that because it should also be that tan of 52 degrees, that's the other angle, okay, tan of 52 degrees is equal to H opposite over adjacent, H over L. Okay. We know what L is. L is 6.564 whatever. So if we want to get L by, or get H by itself, we can just multiply like that. And then we have this to substitute in. We got 6.5643363.066 times tan of 52 degrees equals H. We'll just verify this should equal 8.4. So we'll go back up and grab that value, put it back into our working space there, times tan of 52 degrees. And there it is, 8.4 feet equals h. So the answer to the question is that h is approximately 8.4 feet tall, and that L is approximately 6.56. I'll just leave it like that, feet, approximately that many feet, 6.6 feet, I guess. And that the total distance, AC, is 11.6 feet. All right, so that's how we solve those distances and heights. Thank you so much for watching.